Hello, welcome back to AdMaths plus Maths. Welcome to another discussion about algebra, which focuses on laws of exponents. We are now going to discuss part 2 of the laws of exponents. Make sure before you watch this video, please watch part 1. I'm going to put the video on the card above. Just watch that first before you watch this part 2. So, before we go to the lessons or next lessons about laws of exponents, let's try to recall what we have learned in part 1. Rule number 1. It says, if I am multiplying two numbers with the same basis, but given are your indices, we are just basically adding those indices or exponents. Rule number 2. If I am dividing two numbers with the same basis, given are the indices, I will just basically subtract those indices or exponents. Rule number 3. If I am given a number raised to an index or exponent, but raised again to another index or exponent, then I will just basically multiply those two exponents or indices. Rule number 4. If I am given a number raised to a negative index or exponent, then I will just basically bring down that number and make the index positive. And rule number 5, any number raised to 0 is always equal to 1. Now, let's go to the next rule that we are going to study. This is called fractional indices or fractional exponent. Consider square root of 9 times square root of 9. What will happen? Remember, square root of 9 is 3, and if we are going to transform, it will become 3 times 3. And 3 times 3 is equivalent to 9. If I am going to apply what I have learned about converting a third or a square root of 9 is equivalent to 9 raised to the power of 1/2. Okay? And 9 raised to the power of 1/2 times 9 raised to the power of 1/2. If I am going to apply rule number 1, which is multiplying two numbers with the same basis, I am just going to add the indices or exponent. It will become 9 to the power of 1/2 plus 1/2. And 9 to the power of 1/2 plus 1/2 is 1. 9 to the power of 1, which means it is equivalent to 9. It will be the same thing. So if you try to compare the two things, it will be the same thing. And of course, you will just say that square root of 9 is equivalent to 9 to the power of 1/2. Take note, I have here is square root of 9. The number that is in this part is always 2. If I will change that, I will make it 3, then it will become cube root of 9. And if it is cube root of 9, then it will become 9 to the power of 1 over 3. Okay? This will give us a conclusion that if the index 1/2 means square root, then a to the power of 1/2 is equal to square root of a. The index 1/3 means cube root, which means a to the power of 1 over 3 is equal to cube root of a. This can be written more generally as the index 1 over n means the nth root. So whatever is that n will be the root. So if it is 1 to the power of 1 over 5, then it will become fifth root of the a. So this part means a to the power of 1 over n equals n root of a. If this will be 5, then this will be fifth root. Okay, next, let's try to do some examples. Find the value of 16 raised to the power of 1/2. Remember, raised to the power of 1/2 means square root. So it will become square root of 16. And square root of 16 is 4. Next, letter B, 25 to the power of 1/2, square root of 25. And square root of 25 is 5. Next, we have 16 to the power of 1 over 4. Means it will become fourth root of 16. And fourth root of 16 is 2. Next, I'll have 125 to the power of 1 over 3. Means it will become cube root of 125. So you notice here, let's go back to letter C. It is 1 over 4. It is 1 over n. N is 4, so it will become nth root will be fourth root of 16. Here, I have raised to the power of 1 over 3. N is 3, so it becomes cube root of 125. Remember, if your index is 3, then you will say, instead of square or third root, okay, you don't say third root, but you will say cube root. This part will be cube root. If you will raise a number to 3, then you will say, for example, 125 raised to the power of 3. Instead of saying 125 raised to the power of 3, it can also be read as 125 cube. Okay, so this means this is cube root of 125, and cube root of 125 is 5. Let's move on to letter E. How about if you have a negative index? If you have a negative index, applying rule number 4. Okay, we will apply rule number 4, we will bring it down and make the index positive. Okay, and then change that into a root. Since it's raised to the power of 1/2, then it will become square root of 36. So it will become 1 over square root of 36. And 1 over square root of 36 is 1 over 6. That's the example number 1. 8 to the power of 2 over 3 can be written as 8 to the power of 1 over 3 to the power of 2. Remember, 2 times 1 over 3 is 2 over 3. If you want to apply your rule number 3. Okay? Next, rule number 3 will lead us to 8 to the power of 1 over 3 to the power of 2. Which means 8 to the power of 1 over 3 can also be written as cube root of 8. Cube root of 8 to the power of 2, which is 2 to the power of 2, which is 4. Okay, let's go back to what happened. Remember, 8 to the power of 1 over 3 from the previous slide can be written as cube root of 8. Okay, and cube root of 8 is 2. Then do not remove yet the square, so it will become 2 squared is 4. So the equivalent value of 8 to the power of 2 over 3 is equivalent to 4. This will give us an idea that similarly, 8 to the power of negative 2 over 3 will be 1 over 8 to the power of 2 over 3. Okay? Now, it will now become 1 over cube root of 8 squared. And cube root of 8 is 2. 2 to the power of 2 is 4. So, it will give you an idea that it will become 1 over 4. Next, in general, a to the power of m over n is equivalent to n root of a. So whatever is the denominator over there will become the root, and whatever is the numerator of the index will become the index of the third. Okay, next, find the value of the following. So this will be our example number 2. 16 to the power of 3 over 4. So it will become 4th root of 16 to the power of 3. Okay, because 16 raised to 1 over 4 to the power of 3. But you can directly move from here going to 4th root of 16 to the power of 3. Okay, and 4th root of 16, we all know that this is 2. So 2 to the power of 3 is 8. Let's move on to letter B. 64 to the power of 2 over 3. So it will become 64 to the power of 1 over 3 raised to the power of 2. And 64 raised to the power of 1 over 3 is cube root of 64 raised to the power of 2. And cube root of 64 is 4 to the power of 2 then. Because don't touch yet that 2. I am just changing first. Cube root of 64, it becomes 4. Then you square it, then it will become 16. Next, letter C. 25 raised to the power of 3 over 2. So it will become 25 to the power of 1 half to the power of 3. Means 25 to the power of 1 half is square root of 25. And then you raise it with 3. Square root of 25 is 5 raised to the power of 3. And 5 cubed is equivalent to 125. Next, let's move on to letter D. I have now negative indices, letter D and letter E. I will have 125 raised to the power of negative 2 over 3. You apply rule number 4, it will become 1 over 125 raised to the power of 2 over 3. So the negative 2 over 3 will become positive. Next, 125 to the power of 2 over 3 will change into 125 to the power of 1 over 3 raised to the power of 2. Okay, and 125 raised to the power of 1 over 3 is cube root of 125. Then you raise it to the power of 2. That will become 1 over, what is cube root of 125? It is 5. So 1 over 5 squared. And 5 squared is 25. Thus, our answer will become 1 over 25. Next, letter E. 81 raised to the power of negative 3 over 4. Applying rule number 4, it will become 1 over 81 raised to the power of 3 over 4, wherein the index becomes positive. Okay, we'll change again 81 raised to the power of 3 over 4 to 4th root of 81 raised to the power of 3. I can go directly with that. And then 4th root of 81 is equivalent to 3. So it will be 1 over 3 to the power of 3. And 3 to the power of 3 is 27. Therefore, our answer here is 1 over 27. An additional problem that I add here will be this one. How about if I am looking for the index? How are we going to find out the value of that index? Find the value of n if 2 raised to the power of an index n is equal to 32. How will you find that n? Basically, write 32 as a power of 2. When I say write 32 as a power of 32 of a 2, okay, I am going to find out what should be the index of 2 so that it will become 32. Okay, when I ask myself what should be the index of 2 so that it will become 32, I can also ask myself, how many times will I be multiplying 2 to itself so that it will become 32? I will repeat. How many times will I be multiplying 2 to itself so that it will become 32? Okay? Remember, if you multiply 2 to itself 5 times, it will become 32. So I can write this 2 times 2 times 2 times 2 times 2 to 2 raised to the power of 5. So 32 can also be written as 2 to the raised to the power of 5. Okay? So 2 to the power of n is equal now to 2 raised to the power of 5. You will notice that the bases are the same. Okay? If the bases are the same, then I can equate the indices. I repeat, if the bases are the same already, then I can equate the indices. Restriction: you should have a single base on the left side and a single base on the right side. If it's not a single base on the left and it's not a single base on the right, then you cannot equate yet the indices. You have to apply your rules before you apply this. Okay? I repeat the restriction. The restriction says there should be a single base on the left side and there should be a single base on the right side so that we can equate the indices. So n is equal to 5. So the value of the n is 5. Let's move to example number 3. Find the value of n if 5 raised to the power of n is equal to 1 over 125. I want to convert 125 wherein it can be written as power of 5. Remember, 5 times 5 times 5 is 125. So I can convert 1 over 125 to 1 over 5 to the power of 3. But remember, 5 power of 3 is on the denominator. I will raise it up. I can make the index negative, applying rule number 4. So again, 5 to the power of 3 is on the denominator. Okay? I have to bring it up so that it will be on the numerator. And when I bring it up, I'll make the index negative, applying rule number 4. So it will become 5 to the power of n is equivalent to 5 to the power of negative 3. Since the bases are already the same on the left side and on the right side, and it's a single base on the left and a single base on the right, then I can equate the indices or exponents. So n is equivalent now to negative 3. Next, how about find the value of n if 5 to the power of n minus 1 is equal to 125. I can change 125 to 5 to the power of 3. And it will give us an idea that 5 raised to the power of n minus 1 is equivalent to 5 raised to the power of 3. Since we have a single base on the left and a single base on the right, then I can equate the indices. So it will become n minus 1 is equal to 3. N minus 1 is equal to 3. Therefore, I can bring or add both sides by positive 1 or 1. If I add both sides by 1, n will be equal to 4. Next, find the value of n if 4 raised to the power of 3n minus 2 is equal to 16 raised to the power of 2. You will notice that if I will change that 16 to the power or as a power of 4, okay, this will be 16 can be changed to 4 raised to the power of 2. But again, you have another index there. If you will try to apply rule number 3, I can multiply this index 2 times 2. 2 times 2 is 4. So it's equivalent to 4 to the power of 4. Thus, 4 raised to the power of 3n minus 2 is equal to 4 raised to the power of 4. Since I have a single base on the left and a single base on the right, then I can equate the indices or exponents, which will give us 3n minus 2 is equal to 4. I will add first both sides by 2. Will give you an answer 3n is equal to 6. But I was not able to eliminate yet that 3 to make n the subject of the formula or to isolate n. Okay, so I need to divide both sides by 3. So n is equal to 2. So our answer here is the value of n is equal to 2. That ends our part 2 for the laws of exponents. Thank you for watching this video. Don't forget to like and share it with your friends, most especially those who are studying mathematics. If you did not subscribe yet, please subscribe to our channel so that you will be updated with our new videos. You have to click the bell button with all. Thank you and God bless.